So in the last class, we have seen what measurement of phase and frequency. I told you that if your major axis of your Lissajous curve or Lissajous pattern, sorry, if it lies in your first and third quadrant, then you are going to say that the phase shift is either between 0 and 90 degree, or it is between 180 and 270, like this.
So,
Yes, tell me.
so actually, I checked one question on online, and the major axis when it is one in and 1 and 3, it was saying that 0 to 90 and 270 to 360 phase axis phase
What?
shift.
First and third quadrant. Yes.
Yes, in the first and third quadrant, the phase angle will be 0 to 90 and then 270 to 360. This why I wanted to confirm if it was correct or.
No, no, it's 0 to 90, na? Because you can
Yes, so
see
0
this
to
is
90 and then 270 to 360.
this
You
is
have written 1
180.
and 3, 182 to 270, and in the fourth quadrant, you have written 270 to 360.
Have I
So it
written
was
something else?
actually, yes,
No,
sir.
I have written the correct thing. Major axis, if it is in first and third quadrant, then 0 to 90 degree.
Yes,
This
sir,
is in
this
between
one,
0
yes, sir. But the
and
phase for the 270 to 360, it was again on the 1 and 3.
what I am not getting. Means for this figure, whatever I have said, I will repeat once again. For figure A, it is 0 to 90 degree and 180 to 270 degree. Why? Because you can see this is between 180 and 270. If your major axis lies between second
So this,
and
the 180 to 270, it was lying in the second and fourth quadrant actually.
I am not getting what you are saying. Please repeat once again. Just give me a minute.
So the phase difference which we are talking about calculation. So if the
Mm-hmm.
phase is between 0 to 90 degree, it is
Mm-hmm.
coming out into the first and third quadrant major axis.
Yes, yes, this one,
And
this figure.
yes, sir. And if the
Mm.
phase is 270 to 360, it is also coming out to be the one and third quadrant for the major axis.
Why 270 to 360 it lies in this region?
Yes, yes,
Huh.
sir. So in the first and third quadrant, and you have written 180 to 270, it should lie in the
No, I
first and
have
third.
written second and fourth quadrant. Huh? See, this is from the last class. I haven't done anything. So I have written 90 to 180. This is 90. This is 180. This is 270. This is 360. So if your major axis lies either in your 90 or 180, or if it lies in your 360 to 270, you will say it is second and fourth quadrant only. Means I am not understanding. Where are you confused? Tell me once again. Did I say something wrong?
I
Nitish,
think
what did
that
you say? Tell me.
the phases of the that is 180 to 270, it should lie in that second and fourth quadrant. Because I saw on the internet and I checked twice that what that is was showing
180 degree to
270 degree. It should lie in the second and fourth quadrant
180 to 270. How can major axis lie
because
in your
the axis was rotating like
where did
back
you
and forth.
where did you
So,
see?
okay, so let me check and I'll message you.
No, no, no. Let us do one thing. Let me pause the recording, resume the recording. So I have made a mistake. So very good, Shishir, that you rectified my mistake. Okay. So when it is lying, your major axis is lying in your first and third quadrant. It is 0 to 90 either, or it will be what? Once again, I am writing that 270 to 360 degree. Okay. And if it lies in your what, if it lies in your second, means in this second and fourth quadrant, then it will be what, it will be either 90 or 180, or 180 and 270. Now is it correct? Now is it okay? Means I also have to see this theory part once again. Okay, I will also have to check Okay, so questions I couldn't get because I told you I don't have any material with me and I didn't download also. So question I didn't get. So today we will just cover your theory part. Okay, theory part we will cover. So this is the Lissajous pattern when your phase is 0 degree. This is for 15 degree. For 30 degree, it will bulge out a little. You can see it is bulging. For 60 degree, it will bulge a little more. And for 90 degree, this will be a perfect circle. Okay, phase difference. So these all things are asked in your examination. Let me see if I can download some material, okay, from the internet. I couldn't get hold of my material. So in the next class, most probably I will bring questions, okay. So today we will see what measurement of frequency. Now this measurement of frequency, it is not that tough, okay. So how do we actually measure the frequency? So the unknown signal for which we have to measure the frequency, it is applied to your horizontal plate, okay, horizontal plate or what, vertical deflecting plates, okay. I have written also Y plate. And what we do then, we accurately calibrate this, means we have a standard signal also. We have a standard signal. All this thing, measurement of phase and frequency, it is going on in your XY mode only. Okay, continuously it is going on in your XY mode. So what we do, we have a variable frequency which we give to your X plate. So what we can do, we can calibrate or we can tune basically the variable frequency such that it is either exactly equal to the unknown frequency or it is actually a multiple of the frequency of the unknown signal. When we do that, we get certain Lissajous patterns that we can see. Few of them I will draw for you. Okay, so this is one. Now this is not the proper way of drawing because these are all closed figure, but I am drawing like this. Okay, such kind of patterns you will get. Such kind of patterns you will get. So these are all Lissajous pattern with the help of which we can actually measure the frequency. Okay, measure the frequency. How? So there are formulas also. What? So I told Fi is what? Fi is the unknown frequency. Fx is the known frequency. Okay, Fx is the known frequency. And basically when we get this Lissajous pattern, so what we can do, we can calculate the number of horizontal tangents. Okay, these are the tangents. So we can calculate the number of horizontal tangents. So the formula is basically for calculating the unknown frequency is what? Number of horizontal tangent divided by number of vertical tangents. Now, what is this number of horizontal, number of vertical tangents? So let us see. So horizontal tangents means these are all the horizontal tangents. So here actually you can see the horizontal tangents are two. Either you can take the upper tangent or the lower tangent divided by number of vertical tangents. So vertical tangent, if you draw, you can see there is only one. Okay, there is only one. So this is what? This is your vertical tangent. So 2 is to 1. Now, the moment you have this ratio, so if you know this frequency, the signal means which you have applied to your X plate, you already know that frequency. Okay, because it is a standard variable frequency, you know the frequency. So if you know this frequency, you can get this unknown frequency. Like in this case, if you see, so that will be 3 is to 1. For this it will be 3 is to 1. For this one, if you see, so this will be 3 by 2, because this is 1 2 3, and here you can see, if you draw your, means this is not proper symmetrical, this will also touch over here, but my diagram is not that proper. So here it will touch, this is one vertical tangent, and over here also there will be one cut. So this is 3 is to 2. Tell me, is this clear? This is one way, this is one formula that we got. Okay, one formula that we got. Is it clear? Now another method, you one more method. Okay, one more method, that is your cut method. Okay, cuts. So basically here also, fy by fx is equal to number of horizontal cuts divided by number of vertical cuts. Okay, we have to do this, and we have to do this cuts in such a way that we need to maximize the number of cuts. Okay, maximize the number of cuts. So now let me show you in this. See, if this formula, both of them are correct, this ratio, it will remain the same. Okay, so now first of all, let us see the horizontal cuts. So this is one horizontal cut. Okay, horizontal cut. If you take this horizontal cut over here, you can see that you will get 1 2 3. Okay, 1 2 3, then you will get erroneous result. So always remember, you have to make a cut at such a place that you get maximum number of cuts. So if you take cuts over here, you can see you get 1 2 3 4. So write 4 divided by vertical cut. Now if you take a vertical cut over here, you can see there are 2 points where this is cutting. Now if I had taken over here, sorry, from this middle point, you can see there is only one cut. But if you take it from here, or even from here, you can see what, that there are two cuts. This is one point, this is one point. So this is 4 is to 2. Similarly, you can do it over here also. Okay, if you do it over here, so 1 2 3 4 5 6 divided by 2. So that is once again what, 3 is to 1. Now over here, if you see, if you want to take cuts, so look, we can take one cut from here. So how many points is it cutting? 1 2 3 4 5 6. And if you take vertical cut, see, I am taking from, my diagram is not that proper, but if you take, okay, so it's coming. So 1 2 3 4, so 6 by 4. You can see this is 3 by 2. So basically these two are the formula for calculating what? Calculating your frequency of the unknown signal. Tell me, is it clear? Is it clear? Any doubt in this? Okay. So this is all about your CRO. Okay, CRO. So CRO, this much is enough to solve any question. Now there are few peculiar question. I think in 2003 and 2007. If you see that question, two questions are there. Okay. Those two questions, whatever theory you read, you won't be able to answer that question. Why? Because it is specifically first, it is a theoretical question, and second, it is your practical approach. Okay, practical point of view they are asking. So such kind of question, whenever you see, you need to skip those questions because we don't know. Now we will solve that question also in our class, because as already the question is present, so we are going to solve it. Okay, but there are few peculiar questions that might be asked from your this CRO. In that point we have to skip it because those things are not even there in our syllabus, but they actually put it. Okay, they put the question, so those questions need to be skipped. Okay, so this was all about CRO. Have you guys practiced question about CRO questions? So are we able to solve the questions or not? See, one thing I forgot to tell. Sometime you might even see, I am drawing this line so that it is easier for me to draw the Lissajous pattern or the Lissajous curve. Sometimes you might even see that you get a, you might get something like this. Okay, so this is Lissajous curve. So here also you can calculate the frequency in any formula. Either you take the number of horizontal tangent by vertical tangent, or you take horizontal cut by vertical cut. Okay, so no need to worry that this is not actually a Lissajous pattern, this is Lissajous formula hold or not. The formula is going to hold every place. Okay, is it clear? Is it clear? Any doubt? Any doubt? Okay, fine. So with this, we finish CRO. Now, one thing I want to tell you guys, study basically is written a measurement of voltage, power, energy, power factor. Okay,
Your
power
voice is
factor we
breaking.
have already seen. My voice is breaking.
Yes, sir.
Now is it okay?
No, sir.
Hello. Yes. Hello. Now is it okay?
Yes, sir.
I am sitting in proper Kolkata, yet Airtel is not giving me internet. I don't know why. Okay. So maybe in flat there is some issue or what, I don't know. So let it be. So I was telling what? That we have already seen the measurement of power factor. We have seen. Now, measurement, they have indirectly written measurement of voltage current. Okay. Previously, this syllabus, it was updated in 2020. Why my screen share ended? Am I audible? Is the screen sharing okay?
Yes.
Now it's so what I was telling that basically this part they have actually changed measurement of voltage, current, power and energy. Okay, but actually this is your basic instrument only. Okay, because you can measure voltage, current, power using basic instruments. Previously if you check your 2019 syllabus or 18 syllabus, there is basic instrument written instead of this. Now don't worry, you might think that sir is teaching something else, but with the help of basic instruments only we measure voltage, current, power, energy. Okay, so now our next chapter it is basic instrument. So that's why I want to open window. Okay, you hear a lot of noise. Okay, I hope not that much disturbing.
Sir, you
Is
are
it
not
okay?
audible.
Fine. I am not audible. Just give me a minute. Okay. Wait, let me try some. Is it
Yes,
clear?
clear,
Okay.
clear.
Yes, please.
So I was telling about now we are going to see the measurement of current and voltage. So we are going to basically see your basic instrument because current in any electrical or electronic measurement, either we measure current or voltage or basically we measure some other quantities in terms of current and voltage. That is why the instruments which measure current and voltages, we call it as basic instrument. So that is what I have written in your first point. The instruments that are used to measure the basic quantities like current and voltage are called basic instrument from your electrical or electronics point of view. Okay. So usually in electrical measurement, the responsible quantity is always current, whereas in your electronic measurement, the responsible quantity is always voltage. Can anyone tell me why? Why? Can you tell me? Because we know what in your electronics, okay, in electronic circuit, the value of current it is very less, not many, means it's not like in your ampere region. Okay, it's not like that. So in electronic circuit basically the current it flows usually in your micro or milliampere region. That is a very less current actually. And the basic instrument, they are basically what they are indicating kind of instrument, means there is always a mechanical counterpart which rotates, and what it does, it indicates the equivalent value. So when your current is only very less, so mechanical devices or your mechanical instruments, okay, which measure current, so they basically have high inertia. So due to that, a small amount of current cannot cause deflection. So that is why usually we measure voltages. Whereas in your electrical measurement, the value of current is high compared to your, means you will say that sir, actually when current is high, voltage will be also high. But current actually plays a higher role when we measure electrical quantities, okay, electrical measurements. So whenever you see in this power line, okay, power line, or if you want to measure something at your home, you measure the electrical value like your air conditioner. You measure whether 5 ampere current is flowing or 7.5 or 10 ampere. Like that you measure the current in the line when you are measuring electrical lines, whereas in your electronic you measure voltage difference. Okay, so usually what happens, the basic principle in this basic instrument where we measure current and voltages, we have electrical energy, we convert it into an equivalent mechanical energy to show us the deflection. Okay, now what is this known as, means this instrument which converts electrical energy to mechanical energy? What do we call it as a, tell me? Deflecting instrument, obviously it is deflecting instrument. So it is known as what? It is known as electromechanical instrument, or if we study sensors and transducer, this is basically known as what? This is known as transducers. Okay, so here we are going to take help of transducers to actually measure the equivalent current and voltages. Okay, so now there are basic few torque in our basic instrument that we have to study. The first is what? First is your deflecting torque, denoted by tau d. Next is your controlling torque, defined by tau c. Okay, it is defined by tau c. Next is your damping torque. It is measured by what? It is denoted by tau zeta. Okay, now what is this zeta? Zeta, we know it is your damping ratio. Okay, it is what? It is your damping ratio. So why do we require three kind of torque in this basic instrument to measure current and voltages? We are going to see them one by one in your DD. So the first one is what? Deflection torque. Now what does this deflection torque does? Basically your deflecting torque, it deflects the pointer from the initial position to indeterminate position. Now what do we mean by this statement? Suppose we have one instrument. Okay, we have one instrument, something like this. So initially, this is your zero value, this is your max value. Now initially, when no current or voltage is present, it will indicate zero. The moment the instrument has what? There is some amount of current flowing, which can be the minimum amount of current which your instrument can detect. What will happen? This pointer will start to deflect. Now this deflecting torque, basically what it does, it actually helps the pointer to move in this direction. Okay, it helps the pointer to move in this direction. Now why did I say indeterminate position? Indeterminate position means what? The position which we cannot determine. So now when, suppose if I have one instrument in which deflecting torque is only present, no other kind of torque is present. Don't write, first listen, then you can write. Suppose if we have an instrument in which only deflecting torque is present, suppose this is one ammeter, this is 1 ampere, this is 2 ampere, this is 3 ampere, 4, 5, 6, 7. Suppose I have one ammeter. So now, if only the instrument has deflecting torque, suppose through a line, if 1 ampere current is flowing and I am using this instrument, whatever is the value, suppose 1 ampere, immediately, if only deflecting torque is present, immediately now this pointer will move to 7. Immediately, max value. If 2 ampere is flowing, still this will go to 7. If 3 ampere is flowing, still it will go to 7. Okay, so there is basically no differentiation between the current. Okay, there is no differentiation between the current. So that is why I have written deflecting torque basically deflects the pointer from initial to indeterminate position. Basically what this deflecting torque does, it actually deflects. Okay, it actually deflects irrespective of the value of the magnitude. Okay, tell me, up to this point, is it clear? Is it clear? Fine. Now basically this deflecting torque, it is actually proportional to the quantity being measured. Okay, it is proportional to the quantity being measured. Why? I will tell you. See, I told basically there is no differentiation between this. So now there should be an equal and opposite torque which is going to define or basically segregate or classify different values. Now that provided by controlling torque. So what I have written, controlling torque always acts opposite to deflecting torque. Okay, it always acts opposite to deflecting torque. Okay. Now, why did you might have questioned me one thing. Sir, you are telling tau d is proportional to quantity being measured, and then you were telling that whatever is the value, it will just push the pointer to maximum value. Then how are you saying so, sir? You could have questioned. Can anyone answer?
Sir,
Anyone?
is it because of the controlling curve?
No. Basically, suppose if 1 ampere current is flowing. So for this pointer to go from this point to this maximum value, suppose it takes 10 seconds. Now if it is 2 ampere, from going from this point to this point, it might take what? It might take 7 seconds. For 3 ampere, it might take even less. So whatever is the value, it will be basically directly proportional to the magnitude that is flowing. So you will see that if the value is more, it will reach the maximum value more faster. If it is less, it will reach slower. Okay, that is what I meant over here. Shishir, Nitish, both of you, is it clear? Any doubt? Fine. Now, next what we have is your controlling torque. Now, what is this controlling torque? So, controlling torque basically provides an equal and opposite torque to deflecting torque. Okay, equal and opposite to deflecting torque. Basically, or you can even say it provides a counter torque to your deflecting torque, so that for 2 ampere it will stop at this point. For 3 ampere the needle will stop over here. For 7 ampere it will stop over here. Okay, so this actually equal and opposite torque is provided by your controlling torque. So initially, you should know this, initially deflecting torque is more and tau d is maximum. Okay, so I have written initially deflecting torque is maximum, initially controlling torque is minimum. So you will understand this with the help of an example. What I am trying to say, if suppose I am measuring 4 ampere, okay, 4 ampere, okay. So with this color, green color, I am drawing deflecting torque. So deflecting torque will be minimum, okay. It will be minimum at which point? Sorry, it will be max. Wait a minute. So what I told that deflecting torque. So if I want to draw this, deflecting and controlling torque. Okay, so draw it like this. Okay, this is torque versus time. Suppose I want to measure using this instrument. Now at this point I have both the torque, deflecting torque as well as your controlling torque. Initially, when the measurement has just begun, your deflecting torque will be maximum. Okay, and initially this color is for controlling torque. Initially controlling torque is less, but when this reaches steady state, this is your controlling torque. So at this point you can see your needle is oscillating between 4 ampere, because sometimes your controlling torque is more, sometimes your deflecting torque is more. Both of them are same approximately at your steady state time, TS. Now when do we reach steady state? Ideally, when do we reach steady state?
After 5 tau.
Yeah.
What? Pardon, please repeat once again.
Sir, after 5 tau.
See, that is one approximation usually we take after 5 tau. Usually steady state time is the time after t, okay, t greater than infinite. And what is transient time? Transient time is the time between 0 and infinite. So steady state time is when t tends to infinite. Okay, that is what? That is your steady state time. So this steady state is usually reached at when it is reached at your infinity. Okay, so now if I am measuring 4 ampere, what will happen? This needle will continuously oscillate between a mean position of 4 ampere. Okay, so to avoid this oscillation, what we do? Can you tell me? See, we up to this point, have you understood? Please tell me yes or no. Up to this point, have you understood?
Yes, sir.
Okay, that there are two torque basically acting. One is your deflecting torque, which deflects the needle from initial position. Another is your controlling torque, which is actually opposite to deflecting torque. And controlling torque basically controls the position of the needle to an equivalent quantity being measured. Okay, so now to avoid this oscillation, what we have? We have damping torque such that see, previously this was our, what did I draw? This was our controlling torque, and this one was our deflecting torque. And I told steady state we reach at your infinity time. Now this damping torque, what it does, it is basically done to remove the oscillation at steady state, such that the moment this happens, your measurement becomes like this immediately. Okay, so now can anyone tell me why does this oscillations happen? Why does this oscillations happen? Decaying oscillation? I will only tell, it's okay. So basically, your energy is being continuously released. Okay, it is being released. Suppose if you have one air conditioner, okay, air conditioner. The moment you switch it on, what happens? If this is suppose your room temperature, this is like your, uh, okay, I shouldn't have drawn it like this. If I am taking air conditioner example, so this is your temperature versus time. So you have set your air conditioner temperature to 25 degrees C. Your room temperature is suppose 50 degrees C. Okay. So now suddenly it cannot come to directly, it cannot come to like this, it cannot come to 25 degrees C. It will take some time. Okay, now once this goes below 25 degrees, suppose if your AC, it has a feedback circuit, if it reaches 24.5 degree, what will happen? Immediately your compressor will switch off. Okay, it will switch off. Suppose it switches off for your 1 minute. So when it is switched off, your room temperature will start to increase. It will reach like 25.1, 26, sorry, 25.2, like this it will go. Once again your compressor will start. Once again it will go below 25, compressor will stop. Like this will go on and on till the time you switch on the AC. But you can see for the first time when you had switch on the AC, the time required to go from 50 degree to 25 degree, it was more compared to the time next time it went from 25, means from this point 24.5 to this point. And now this temperature gap will also decrease, and your AC, it will switch on at a higher time. Okay, tell me yes or no what I am trying to explain. Are you getting this? Are you getting
Yes,
this?
sir. Yes, sir.
Okay, so what we need to do, basically we have to remove this part. Okay, we have to remove this part. So we use a damper. Now what are all these dampers? Basically these dampers are used to remove the excess energy which is causing this oscillation. So in mechanical system, these are basically caused due to the inertia. Okay, inertia. So inertia actually causes this. So what we do, we have some dampers which removes this excess energy so that we don't get this oscillations. Okay, so when we study your basic instrument, at that time we are going to see all this torque. Okay, so first, basically few questions have been asked from your controlling torque. Okay, so in basic instrument there are two types of controlling torque. One is your spring control, another is your gravity control. So what happens in your spring control? So in spring control, basically the controlling torque is provided by the spring. We have a spring connected. So this is your mean position of the needle. Sorry. So this is the mean position of the needle. And this is your basically the equivalent position of needle, showing an equivalent amount of either current or voltage. Here in this case, your controlling torque is provided by the spring. Okay, so deflecting torque is actually due to the cause can be either voltage or it can be current. Okay, due to which we get this theta effect. Okay, now for controlling torque, TC is what? Basically this is your controlling torque which is proportional to TD, which is proportional to TD. Okay, like I will tell you, suppose you are riding your motorbike, okay, motorcycle. So tell me, if you are traveling at 20 kilometer per hour, okay, 20 kilometer per hour, will braking be that tough compared to when you are traveling at 60 kilometer per hour? So when will braking be tough? If suppose I tell you, that you need to stop your motorcycle within 10 meters, okay, so when you are traveling at 20 kilometer per hour and you want to stop your motorcycle within 10-meter distance, you need not press the brake pedal very hard. Okay, you don't need to do that. Why? Because your speed is less, so basically your momentum is less. So that is why the brake means the force with which you press your brake, what is that called, brake handles or your brake pedals in your foot, that is very less. But when you are traveling at 60 kilometer per hour, you need to press the brake pedal hard compared to this 20 kilometer hour. Okay, 20 kilometer per hour. So same is the controlling torque also. When your controlling torque, when your equivalent current, if it is less, at that time the controlling torque required will be also less. When it is more, suppose your current is more, you are measuring 5 ampere, 6 ampere, at that time the controlling torque is also more. Okay, so your basically this controlling torque is proportional to TD. Up to this point, have we understood? Please tell me yes or no. Any doubt in this? Any doubt? Clear? So here basically this controlling torque is produced by the spring force. Okay, spring force. So if I told you TD is basically proportional to theta, That means TC is also proportional to theta. Okay, TC is also proportional to theta. Now we know if I remove this proportionality sign, so TC is equal to K theta, where this K is actually your spring constant. Okay, it is your spring constant. So usually the spring that we make, it is usually made of alloys. Okay, alloys like your this thing, what, silver and phosphorus alloys we make usually the springs. Okay, to it show, so that it remains sensitive to your deflecting torque. And one more thing, let me ask you, is this equation linear? Is this equation linear? Is this equation linear? Okay, you are telling me linear. Very good. This equation is linear. If it is linear, then what do you think? It's basically, I told you that TD is directly proportional to theta and TC is directly proportional to TD, hence TC is directly proportional to theta. So when this relationship is linear, at that time error is also less. Why? Because both of them are linear relationship, error is less. So always remember that when we have spring control, error is less. Now there is one more controlling torque, that is your gravity control. Okay, gravity control. So we have a heavy mass over here which actually produces an equivalent but opposite torque to that of controlling torque. Now this time what happens is that we have one mass over here. Okay, mass over here. So let me assume at this point this is your initial value, this is your final value, this is your final value. So when this is your final value, what will happen? This mass will move over here. Okay, and this will be your needle. So this, if this is your needle, so this will be your mg. So this side, and we will have over this side. So basically this will be what will be this. Okay, let me explain it over here. So this is the mass, this is the needle. Okay, so this much angle, so this was the initial position of the needle, so this much is theta. Okay, let this be mg. So where is theta? Where is theta? Which is theta?
I could not get your question.
Over here, which is theta? I am just asking. Where is angle theta? Here, here. Where theta is angle? Can you tell me? See, if this angle is theta, if this angle is theta, okay. So that means what? See, this is also the same angle. Okay, this is also the same angle. That means if this angle is theta, okay. So I am confusing you guys. So let me remove this. So this is now the position, actual position of the needle, which is balanced by this mass. Okay, this was the initial position of the needle. This was the initial position. Deflection is by theta. Okay, I am resolving this force into two parts. So this is the mass mg. Okay, So now tell me over here, where is angle theta? Tell me, array, if this is theta,
So
what you
between
can do?
mg and
See, I will only do. It's okay. See, this angle is what? This is theta. Okay, this is theta. So this will be what? This will be 90 minus theta. If this is 90 minus theta, these two are perpendicular axis. So this will be theta. Tell me, is it clear now? Is it clear?
yes,
If this is theta. Now, if this is theta, this will be mg cos theta. This will be mg sine theta. Okay, mg sine theta. So over here, which is actually balancing this needle? Please tell me. This is the now position of the needle. So which force is balancing the needle now at this point? So basically, this mg cos theta is balancing the weight of the needle. Weight of the needle. So here the controlling torque is equal to mg cos theta. But what we know that TD is directly proportional to theta. Okay, TD is directly proportional to theta. And over here you can see TC is equal to mg cos theta, or TC is directly proportional to cos theta. mg is constant. mg is constant. So is there a direct relationship between these two? Please tell me yes or no. Yes, very good. mg cos theta. Very good, Shishir. Is there a direct relationship?
No, sir.
There is no direct relationship. Okay, there is no direct relationship. Basically, this will be inverse relationship. Okay, inverse relationship, or you can say this is non-linear. Non-linear. Why? Because this is not a straight line passing through the origin. So if this is cos theta and this is theta, we know what cos theta is something like this. Okay, for positive angles I am telling. So it is like this. So obviously what will happen, sorry, I have drawn the wrong value. Okay, it will be something like this. So this is a non-linear relationship, so that is why error will be more compared to spring control. Okay, so remember this point. Why? Because there is what? There is your non-linear relationship between the controlling torque and the deflecting torque. Due to that, there will be non-linear relationship. Okay, is it clear? So error will be maximum. Any doubt in this? Any doubt? Okay. Next, what we have? Next we have is permanent magnet moving coil. So what we can do is permanent magnet moving coil equivalent circuit of MC. Okay. So tell me one thing. Okay. Monday, if I start the class from 10 a.m. and if I go till 1 a.m. 1 p.m., will that be okay with you guys? Because I need to go back home once again. It's already 10. I won't get anything. Okay, to travel back. Because I am sitting at one empty flat. Okay. So I have to go once again home.
Yes, sir. It will be fine.
It will be fine with you guys. Okay.
yes,
So let me do one thing. Let me do one thing then. Monday, tomorrow's class. Let me see if I am available tomorrow. We will have class. Okay. Because this class we need to finish as soon as possible. Because the next class is control system. I need to start control system. and whatever is the case, I have to keep working so that you guys don't get delayed. So I need to finish this week only, this topic. Okay, this subject we need to finish this coming week only, so that from the next week onward we can start control system. So let me see if I can take one class tomorrow. Okay, either Shishir or Nitish, just message me, or I will message you guys if I am available. Okay, no need to message me. I will message you guys, text you guys that I am available. Are you guys also available? Or if I am not available, so Monday I will let you know the timings. Okay, is it okay? Is it clear?
Yes,
Yes,
sir.
sir.
Okay. So today we will